Hi there. Today we're going to walk you through mCloud Dashboard and show you how simple it is to create and manage virtual data center or virtual machines. If you're not familiar with the term virtual data center, it's just a pool of resources for compute and storage, which allows you to build your virtual machines. If you only have one virtual machine, that's all right too. There's an extra feature you won't need from this tutorial. This video doesn't require any previous knowledge, but if you are familiar with dashboards like VMware or AWS, you'll see how easy and feature-rich mCloud is to use. Let's jump in. So this is the mCloud environment. On the left, we have our navigation bar here. Under the compute section, we have instances, images, key pairs, and server groups. These are about managing the compute that you deploy into your new VDC. We have the volume section, which is where we manage disks and storage for your VDC. And then we also have the network section, which is where we handle networking, private and public networks, floating IPs, security groups, things like that for your new VDC. So let's start off in networks, and we're going to go and deploy a new private network for your VDC that your VMs will use to communicate with each other. So on this first page, we're going to give it a name, and we do want to create a subnet, and we do want to enable this network. And we'll go to the subnet tab. We'll give this subnet a name and an IP address range. Now this IP address range does not have to be unique. It's going to be created in its own encapsulated software-defined network within mCloud. So this doesn't have to be unique. This can be whatever you want it to be. And we'll define a gateway IP as well. And then on the subnet details page, we're going to provide an allocation pool from that subnet. This is IP addresses. They're going to be handed out by OpenStack to VMs we create on this network. We'll start that at .10, and that will go to .50. And then we need to define some DNS servers that will also be handed out to our clients. Once that's all filled out, we can click create, and that's going to create our private network for us. Now that private network is ready to deploy virtual machines onto. However, at this stage, they would not have internet access if we did so. So the next thing we're going to do is we're going to create a router for that private network that will allow for internet access. We can then click on create router. We'll give that router a name, and we'll select the public network as our external network and click create router. Once that router is created, we can then click on the name of that router and then move to the interfaces page and click add interface. On this page, we're going to add an interface on our internal network that we created previously. And we're going to give it the IP address 10.1, which is what we set the gateway to previously. Click submit. Now that that interface has been created, we can go and we can start deploying virtual machines onto that private network. And so we go to the compute and instances page, and now we can launch our instances. So we'll click the launch instance button, and we'll give these instances a name. We'll select the kill site availability zone, but if you have purchased geographically redundant services, you can also use the other two availability zones. And in this case, we actually want to deploy 2 VMs, so we're going to change the count to 2. On the source tab, we're going to select the image we're going to use as the source for our new VMs. In this case, I'm going to choose Windows Server 2022, but Micron does maintain a full list of images that you can use to deploy, including Linux, Windows, and network appliances. And then we're going to select our flavor. A flavor is the definition of how this VM is created, how much resources it utilizes. In this case, we're going to choose 4 cores and 4 gigabytes of RAM. And we're now going to choose the private internal network we created previously. And as far as these options go, we actually don't need to fill anything else in. So we're going to click launch instance. And now that these VMs are active, we can click into the instance, and then we can go to the console tab and we can watch these as they boot. So all of mCloud's Windows images on first sign-in are going to prompt you for a new administrator password. So we'll enter one now. While this system logs in, We'll go to our other VM and we'll also reset the password for that one. So we'll select yes, as this is a private network and there's no issues. And as you can see, we can now ping the internet through our router. And on our first instance, we'll ping our second instance to show that we have local network connectivity as well. So now we'll have a look at security groups and how those function in mCloud. Currently, our default security group just has rules to allow all access in and out. And obviously that is not security best practice. So we're going to create a new security group specifically for our Windows VMs, just as a proof of concept to show how these work. So we'll create a new security group. And by default, our security group is going to allow all egress traffic. In this case, we will actually block ICMP outbound specifically, just to show how this works. So we'll delete the IPv4 rule, allowing all egress. And we will instead add a TCP and UDP egress rule, but we will not add an ICMP egress rule. So now we can go back to compute and instances, and we can apply this security group to our mCloud VM1 instance, and we'll remove the default security group as well. And we'll click save. And now when we access the console for this instance, we can no longer ping between hosts. The next topic we'll talk about is floating IPs. A floating IP is a temporary IP pulled from the public pool that will allow us to connect into a private network while that floating IP is assigned to that instance. So here we can click associate, and then we could select the port we wish to associate that with. In this case, we'll associate this with 192.168.10.43 on mCloud VM2. And once that completes, we can go back to our instances tab, and we can now see that that IP shows up as attached to that instance. And if we open up our terminal, we can now ping that floating IP that is attached to that VM. So now we'll have a look at volumes, which is storage in mCloud. As you can see, we currently have 2 volumes in use. When you go to create a volume, you can choose a source. If this is going to be a new boot volume, you might select image and then choose one of the images to duplicate onto your new fresh volume. In this case, we're just creating an empty volume. For the type, you may or may not see multiple types of storage here. If you have purchased other types of storage, you would obviously see those types of storage here. We're going to use performance NVMe. However, to give you a quick explanation, geodiverse NVMe multi-site storage is on a special cluster we have built that is spread between 3 data centers in the Melbourne region that provides highly available and geographically redundant storage to VMs on mCloud. Performance NVMe encrypted is the same storage backend as our performance NVMe storage. However, it is encrypted on the fly by mCloud. The standard hybrid storage is a 10K SAS storage with NVMe caching And the bulk SAS storage is a bulk storage built on 7K SAS. I'm going to select the kill site availability zone because that is the only location for the performance NVMe storage. And now that that new disk is available, we can attach that to one of our existing VMs. And click attach. So now we'll return to instances and have a look on a console and see that volume in the VM. As you can see, that new volume has been found by Windows and can be brought online. And initialized. And finally, we can create a partition on that disk. And now we'll go back to volumes and we will extend that volume to make a larger disk in Windows. So to extend, we go to volumes, and then we select the drop-down box for the volume we're looking to extend. We select extend volume. We'll change that from 1 GB to 2 and click extend volume. Once that completes, we'll return to our VM. As you can see, that the new disk size is reflected in the disk. And as you would on any Windows system, you can now extend that disk to be 2 GB instead of 1. So that wraps up the product overview of the mCloud platform. As you can see, all the resources we have consumed during the demo today are now reflected on the overview page. We've used 8 CPUs, 4 CPUs each on our Windows VMs, 8 GB of RAM, 4 GB each on our Windows VMs, and then 82 GB of storage. We used 40 each for the OS disk for our Windows VMs, and then 2 GB on our additional disk. We've used 1 floating IP, 7 security group rules, and we created 1 network. We covered a lot in this video, but hopefully you gained a good insight on how mCloud can assist with getting your services online. There's a lot more to mCloud. You can check out the advanced features in other videos. If you'd like to find out more, please check out the information on screen below. Thanks for watching.